So this lecture is looking at the nomenclature of polyatomic ions. So just to kind of review the last lecture that we looked at binary compounds. And so over here, where we looked at ionic compounds, and we said, how many different atoms are there? And right here where it says 2, if there's 2 atoms, that's binary, right? Like bicycle has 2 wheels. Binary ionic compounds have 2 different elements, a metal and a nonmetal, like Na and Cl, like aluminum and oxygen, like iron and bromine. So these are our binary ionic compounds. What we're focusing on today is polyatomic ions, and poly means many, so more than 2, meaning at least 3 or more. So if we look at, for example, this first example, NH4Cl, notice that there's an N, there's an H, there's Cl's, so that's 3. The one underneath that, Na2CO3, we have Na, we have C, and O. That's 3 different species as well. The last one underneath that, it says FeNO3 parentheses 2. So we have Fe, N, and O. Again, 3 compounds. So this is called polyatomic ions, and that is what we're looking at today. Now again, remember, ionic compounds, same with polyatomic ion compounds, contain ions, but the whole thing is overall neutral. There's no positive or negative charges written. Same, just like what we talked about with binary ionic, is same is true for polyatomic ion compounds. We're following those same rules. Again, we're always going to have the cation listed first. We're going to have a metal for cation. We use the metal name. So if it's K+, we say potassium. Now our only difference here, only possible difference, is we are adding a cation. We are now adding down here a new cation. See, our cation is ammonium. And ammonium is NH4 with a +1+ charge. So that's a group, just like Li +1 is lithium. We are putting this in that same kind of group. We're saying NH4 as a cluster, it's a group. We can't split it apart because it is an ion. A nitrogen with 4 hydrogens together has a charge of +1. So that's our only addition. We still do, if it's a transition metal, we say the name of the metal like iron and then parenthesis, put the Roman numeral with its charge. Again, the only addition to our cations is that we might be able to have this ammonium handy or included. Then we look at anions. Let's see if this works. There we go. Anion is always listed second. If it's only one type of nonmetal, we would still change the ending to I, like oxygen turns to oxide. But if there's 2 or more nonmetals, then it's a polyatomic anion, and we just use the name below, which is nice. So for example, here are a bunch of anions that are very common that we'll use. So so the ion name, so when there's an NO3 together with a -1 charge, we call that nitrate. And again, this is a nitrate ion. We just didn't write ions under here just so you didn't get confused, but these are ions. See, they are anions. They are all negatively charged. So remember, the only positively charged cation that's a polyatomic that we'll use is ammonium. All of the others are negatively charged. So we have nitrate, we have hydroxide, we have cyanide, acetate, sulfate, chromate, carbonate, phosphate. This chart, yes, you will have it as a reference for the rest of the problems. It will be given to you on the test. You just need to know how to read it and how to use it. So I think the best way to get started here is to do some practice problems. So it is important to look at what we have. So when I first look at this whole compound, I look at this and I go, oh, I have K, I have N, and I have O that is more than 2. It is not a binary compound. No, it's more than 2, so it's 3. It's gotta be a polyatomic ion. So if it's polyatomic, the first thing I like to look for is it ammonium? Does it start with NH4? No. So then it's got to start with a metal. And my metal listed here is K, which is potassium. All right, and we know that K is +1 because it's in the first family of the periodic table. Then we need to look at this, and I cannot say that it's nitride oxide. No. Ionic compounds and polyatomic ion compounds can only have a first name and a last name. Okay, we're not doing 3 names just because there's 3 elements. No, so I know potassium, so then that means that this next unit has to have a name. So what is NO3? That's when we go, oh, NO3, NO3, NO3. Oh, here it is, nitrate. So I'm going to call it potassium nitrate. But let's make sure that everything is equal, because remember, my compound still needs to balance out. So we know K is always +1, and NO3, it tells me right here that it's -1. So +1 and a -1 is balanced out. So my compound right here is potassium nitrate, first name, last name. Okay, let's look at the second compound. It starts with a Ca. We know the Ca is calcium, and we also know that calcium is a 2+ ion because it's in that second group in our periodic table. So that's our first name, Ca is calcium. Now we need to have our last name, our second. And look at this, we go, oh, that's definitely more than 1 element. NO3. Oh yeah, hey, NO3, we just found out up here is a -1. So if I have a Ca 2+ and an NO3 with a -1 charge, does a 2+ and a -1 equal out to 0? No, I need to add another -1. So I need another NO3 -1 to give me -2 and a +2. That's why, if you notice here, it says NO3 parentheses 2. That's telling me that I need 2 NO3s for the 1 calcium. So here I've got 2 NO3s to 1 calcium. So I'm just going to call this calcium nitrate. All right, let's look at this next one. Al, we know, is aluminum, and it has a 3+ charge. All right, then I look and I go, oh, SO4. What does SO4 mean? I'm going to look up at my chart here and see that SO4 2-. So I'm going to put a little 2- up here. SO4 with a 2- is sulfate. So aluminum sulfate. Now, if that's a SO4 2- and aluminum is a 3+, notice that it tells me I need 2 aluminums. So I've got an Al3+, Al3+, so that's a total of +6. And this tells me that I have 3 SO4s, which would make sense because each SO4 is a 2-. So that gives me -2, -4, -6. So +6 and -6 would be a neutral compound. Now we get down here and we go NH4Cl. How do we name that? N is nitrogen. That's not a cation, right? We have to start with a metal. So that's interesting, right? Well, remember we added up here a new cation, NH4, which is right here. NH4 is ammonium, and that's our cation. So I'm going to name that ammonium, and that's a +1. And Cl is a -1, and that is chloride. So this is ammonium chloride. And I only need one NH4 and one Cl to balance that compound out. Here's another NH4 and another NH4. So let's look at this and go, okay, NH4, so that's ammonium. And that's a -1. And here's two more elements, but again, we got to look up at our anion polyatomic because this is more than one element. So that means poly. So we're going to look at our hydroxide, which is a -1 charge. So I have NH4 as a group is called ammonium. OH as a group is called hydroxide. So we have ammonium hydroxide. And again, I have a plus, oh, that's supposed to be a +1, a +1 and a -1, so that balances out to a neutral compound. Our last one here, we have NH4. This tells me I have two NH4s. So we know each NH4 is a +1. So I have NH4 +1, another NH4 +1. So I have a total of +2 for NH4s. And then I have, again, another chunk, must be polyatomic. We have to look up what is CrO4. And so here we go. CrO4 with a 2- charge is, with a 2- charge is chromate. So I've got ammonium, chromate, and I only have one chromate. It doesn't say like parentheses with a 2 or parentheses with a 3. So I have a CrO4 2-. So I've got a 2- and 2 pluses, which balances out to be neutral. So now let's try writing the compound from the name. So we can look at this. Let's do what we know first before going back to the polyatomic ion chart. So we know sodium. Sodium is Na, and we know that it's a +1 charge. Acetate, oh, that's one of those polyatomics. We'll come back to that. Lead 2, we know that lead is Pb. I remember peanut butter lead. Peanut butter jars are heavy, like lead, right? This 2 means that it's a 2+. Carbonate, that's polyatomic. We'll go back and find that in a minute. Lead 4, so we're going to have Pb +4. Sodium, that's an Na+. Magnesium, Mg, that's a 2+. And ammonium, oh, we just did that one, right? That's NH4 +1. Okay, now we're going to flip back. We're going to find what acetate is. So let's go back to here. Acetate, C2H3O2 with a -1 charge. C232, I messed that up. So then when we look at combining these, I have a +1 and a -1, which balances out to 0. So to write this compound, I just need to smush them together. It would just simply be Na, and then I can do C2H3O2, and that is sodium acetate. Now let's go back and find, for this guy, carbonate. And carbonate is CO3 with a -2 charge. So CO3 with a -2 charge. So here I've got a +2 and a -2, which balances out to 0. So to write this compound, I'm just going to do PbCO3. That is lead 2 carbonate. So since we know what carbonate is with a CO3 2-, how do we get balanced out with a +4 and a 2-? We need another 2-, right? CO3 2-. So 2- and 2- is 4-. That balances out with a 4+. So this compound would be Pb, there's only one of them, and then I'm going to put parentheses because I need 2 CO3s. So CO3, 2. Now again, that parenthesis, this tells me how many I need. So I need 2 CO3s. That's how that is read. All right, let's go back and find out what cyanide is. And cyanide is Cn with a -1 charge. So Cn with a -1. So I've got a -1 and a +1. So this one is just NaCN. All right, let's look up sulfate. Come back here. Sulfate is SO4 2-. So here we have a 2- and a 2+. So this is MgSO4, magnesium sulfate. All right, and now let's look up acetate. Acetate we used back here in this first example, which was C2H3O2 with a -1 charge. I've got a -1 and a +1, which will give me a neutral compound with just one of each. So NH4 is ammonium. C2H3O2 is acetate, ammonium acetate. Again, notice these are our polyatomic ions. They all have a first name and a last name. Sodium acetate, lead 2 carbonate, lead 4 carbonate, and so on.